Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Rat Run 26 Hit and Miss by Marty Sears. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Aim of experiment. F and P must both reach the cupcakes by finding a path through the maze. The paths must not visit any cell more than once, cross themselves or each other, or pass through any thick maze walls. The paths may not share cells except where they meet at the cupcake cell. Okay. So that means F and P have to be able to have paths that do not share cells. They can't visit any cell more than once, or cross themselves or each other, or pass through any thick maze walls. So you cannot go through a wall here. And they have to, they cannot share a cell except for when they both reach the cupcakes. As well as moving orthogonally, they may move diagonally if there's a 2x2 space in which to do so, but may never pass diagonally through a round wall spot on the corner of a cell. So, for example, F could do something along the lines of, oops, I'm on the edges only. F could do something along the lines of something like this. That would be valid. But could not go like that because that would be going through a round wall spot. And that's how these F and P can move in this puzzle. We have black. I recently just looked this up. It's black currants, I believe, is how it's pronounced. I always pronounce it sort of like as a Frenchified version, like currants, but maybe that's not correct. In fact, actually, I guess that isn't correct because I think it's supposed to be black currants or something like that. I don't know. I'll still call it black currants because it sounds, I don't know, see, maybe a little high and mighty. Maybe it's too Frenchified or something. But I've always pronounced it as black currants, but I think the actual pronunciation is supposed to be black currants. It just sounds so, I don't know. It sounds less elegant to use black currants or something. But anyways, we have black currants, where if two digits are separated by a black currant, one is double the other. So, for example, if this were, say, these are black crop key dots, essentially. If this were, say, a 2, this would have to be 1 or 4 to maintain the 1 to 2 ratio, or make sure that one is double the other. We have grapes, where if two digits are separated by a grape, they have a difference of at least 5. So if this were, say, a 3, this would have to be 8 or 9, because the only digits which are 5 or more away from 3 are 8 and 9. And that's how these grapes work. Test constraint. In this experiment, 3x3 box borders divides both rats' paths up into segments. So that means these are region sum lines. So therefore, interesting. So therefore, if this were, say, F's path, well, okay, this is not valid, but let's remove that aspect. Say she had a path something like along the lines of this. So therefore, box borders, 3x3 box borders, divide both rats' path up into segments. So this would be a segment, 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 and this would be a segment. Oh, we don't even know if it's region sum lines, though. Ah. Okay, so it's not a region sum line. Um, okay. Not all blue hexagonal platforms need to be visited, but any blue platform that does get stepped on becomes a hit counter, where its digit will indicate exactly how many digits along its path segment match their position number. And the first cell visited along a segment is position 1. So as an example, let's remove this and connect here. If Finks visits the digits 9, 7, 3, 2, 5 in that order along a segment, so this is a segment because 3x3 box borders divide the line into segments. So we have an example segment here of 97325. Then 2 would be on its blue hit counter because 2 digits match their position number. 3 is visited third and 5 is visited fifth. So obviously this wouldn't work because this is saying 3 is the hit counter because it's on the blue platform. Interesting. Right, and that's the only test constraint we have. So we don't have to visit all these blue platforms. But if a path does cross the blue platform, that must count how many hits that the segment is matches its step along its position along the segment. Right, so this would be first position, second position, third position, fourth and fifth position. Obviously, since this is third position and it's 3, that matches. If this is fifth position and 5, it matches, which means we have 2 matches on this segment. So that's how these segments work. So this is not a region sum line. Apologies for that. I jumped the gun there. This is just basically the line is divided into segments, and it's specifically to match these hit counters. Where if F or P steps on these hit counters, then the number of hits must match the digit on the hit counter. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, F has to go this way. P has to go this way. So they must go onto the hit counter. Both of them. And they have to be the third one. But F has to continue out. So F is going that way. And P could continue in this puzzle or could go out. So F matches at most 3 cells here. So 1, 2, 3. P could match up to 5 because P could go this way. Or P could go this way. Or P could exit out. So this is at most 5. If it can't actually match 5 because then this would be the third digit, right? So it can't actually match a total of 5. We need at least one matching here, but it could be the fourth and the fifth digit here. So how does that work then? This cupcake can go either 1, 2, 3, or 4 directions, so that's not helpful. But how does this work? Can this ever be 3? If you have 3 matching, it must be 1, 2, and 3. Which means this can't be 1, 2, or 3. It would be 4. But these can't be 1 or 2. And so this can't ever have 4 cells matching then for this segment. So this can never be 3 because that forces this to be 4. We have 1 or 2 that are matching. If it's 2 that's matching, then this doesn't match. 2 doesn't match the third position. And it would have to be 1, 2. So this cannot be 2. Therefore, this is 1 that matches. 1 cannot be here. So this has to be 2 that's matching on the segment. So this is 2, this is 1 that matches. This can't be 1 or 2. It has to be 3 matching then, because it cannot be 4, because 1 and 2 can't be here anymore. So this must be 3 that's matching, which means it has to match 4 and 5 here. So this has to match 4 and 5 here. It goes out here. So then this is 4 and 5. That means the remaining digits, so this green has to go this way. Cannot be 1 or 2. Has to match then at least 3. Could do something funky like that. So could be, so this is 3, 4, or 5 that are matching in the segment. This has to be at least 5. This can be 4 at most, so this must be matching at most. So this is 4 at most here. Can it ever be 3 matching? If we have 3 matching, the third digit is not going to match either. So it cannot be 3. This is 1 or 2 matching. None of these can be matching. So let's point out the matching cells. This matches. These do not. These match. That's 3. These do not. You can't go back here, so this is not going to be valid. We have to exit out here or here. But the thing is, this is going to have to go here somewhere. So it has to be at most 5 here, which means this has to exit out this way. So then P has to go out this way. And we don't know if it goes there or there. So this could be 2 matching. Actually, can it? If we have 2 matching, it can't be the first, it can't be the second, it has to be the third and the fourth. But then that would force this to be 3 and 4, and we already have a 3 in the column there. So this cannot be 2 matching, it's 1 matching. So obviously this is not going to match. Let's make it red then, for not matching. This obviously doesn't match. This cannot match. This can't match because it's 2. 1 matching means this is the only one matching, so nothing else can match. So it could just exit out this way. We don't know. This is 3, 4, or 5. It can't be 5. If it's 5, then the problem is these 3 don't match, and we have 4 at most. So then this is 4 or 3 matching. If it's 3, it could be all 7 digits here. This has to go this way, because otherwise we don't have enough matching cells. It cannot just be 3 this way. If it's 3 this way, the problem is you would have to have 3, 4, and 5 here. But 5 can never be 5 or more away from another digit, which it would have to be with the grapes. So it has to go in here. And because it goes in here, it must continue all the way around. So then this must be red continuing here. So this cannot be 2. So this is not matching. If we have 4 matching, this can't match then. And we'd have to match here, which would have to be 5, which is not possible. So this cannot be 4 matching. It's 3 matching, which 3 forces this to be green. 4 and 5 cannot be here, so they don't match. So these must match, and they must be 6 and 7. So we have 6 and 7 there. This is 1 or 2 to be in 1 to 2, or to be 5 or more away from 7. Therefore, that makes this 6 through 9, but this can't be 6 because of 6 in the row. So this is 7, 8, or 9 here. This cannot be 1 matching. So this has to be at least 2, which means the segment has to go this way. So the segment has to go here. If this is 2, so this could be 2 or up to 9, but it can't be 9 because this would have to be 1. So this is never matching here. This is never matching as a 2. This is never matching as a 3. So this has to be 2 through 6 here, potentially, because you could just continue in this path. F has to go down here. So F goes here, has to go around here, has to connect to there, and this must be at least 4 here. So we have at least 4 that way. This can't be 2, so 2 has to be one of these 2. Because 2 can't be here, 2 can't be here in the box. This is at least 4. We have up to 9 potentially. Actually, it can't really be 9. It could be 8 at most, but it can't go through all 9 cells in this box. So this is 4 through 8. This does not match because it would have to be 3. So then that eliminates 1 cell as a possibility. So this is 4 through 7. This has to continue on this way. This could match as a 4. It has to match at least 2. So it cannot go this way. It could go here or here. One could be here. 2 cannot be here. So that can't match. Which means this cannot be 7 then. Remaining digits in box 1. These can't be 6 or 7, so this must be a 6-7 pair. That leaves 8 and 9 remaining in column 3, which eliminates 8 and 9 in the rest of the column. That leaves the remaining digits in column 3 as 1, 2, 4, 5. This can't be 1 or 2, because again, this cannot match. So this could be 1 or 2 here. These two cannot match. Can this ever be 6 then? If this is 6, that would mean this matches if that matches, and we have 4 other matches, so this can't be 6. Can it be 5? If we have 5 here, that means this can't match. This has to match. We'd have 5, 6, we'd have 5, and the 5 doesn't match. So the 4 and the 5 wouldn't match. We'd have no 3 matches. So this cannot be 5. This has to be 4. So this is 4, which eliminates 4 in the rest of the box. So this is 1, 2, 5 as a triplet, which eliminates 1, 2, 5 in the rest of the column. This matches because it's 4. This can't be 1, 2, or 5. It's 4. Remaining digits in box 4 have to be 2, 5, 8, and 9. And this can't be 5 here because of 5 in the column. This can't be 2 here because of 2 in the column. Again, that means we have a 5 guaranteed here, a 2 guaranteed here. Remaining digits of column 1. We have 6, 7, 8, 9, because we cannot have 5 because of 5 here. And remaining digits of column 2, we have 3, 6, 7, 8, 9 as possibilities. Again, these two cannot match. We have 1 matching here. 4, 5 cannot match. So the 5 cannot match. That means 6, 7, and 1 8 cannot be matching because 8 would have to exit out. So that means the 1 has to be matching. 5 can never match wherever this is. We have to have 6 and 7 match then for 4 to match. So then this must be 1. We could do some... This then has to be 6 and 7 in some order. And it cannot be both 6 and 7 here. So that has to be like 3 blank 6 7, and then the exits out that way. It cannot cross itself, so it cannot do that and then go that way. So this has to, so F does have to go here, 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 then exit out. So this must be then 6 7, because this is never going to match, and these must match, and this can never match. This is going to be in a 1 to 2 ratio, so it can't, and 1 can't be here, so this can't be 5. Therefore, this is 2 and 1 here. This is 5 here. No 6 or 7 remaining in the box. So this is 3, 8, 9. 7 eliminates 7 here. So that's 6, which makes that 7. This is 2, 1 as a pair. F is going to have to get through here, because she's blocked by P here. So F has to go this way. P, we don't know which way she's going. So F has to go through here. P has to eventually go through here. So P must go through this path. F has to continue through here. Whoops. This is a 1 to 2 ratio, and it cannot have a 6. So this has to be either... It can't have 1, so it's either 2, 4 or 4, 8 here. And one of these two is a 4. We don't know which. Can't be 6 because of the 6 in the row, so that can't be 3, 6. Can't be 1, 2 because of 1 in the box. 1 eliminates 1 here, so that's 2. That means this cannot be 2 here. This cannot be 4. We have to match at least 3 times. And it could be up to 6, maybe? No, if it's... It can never be 6, because if it were 6, okay. Also, this P cannot stay on this line through this hexagonal plate, because then these plates would be the same. You'd have the same digit there. So P cannot match 6. Can it even match 5? I think the answer is no, right? 5, you have 5 not connecting. You can't go through all 9 cells anymore. And the 5 doesn't match. And then we have these 3 not matching. So that's not going to work. So this must be just 3 matching. So this is 3 matching. Obviously this doesn't match. It's 1. This could match as 2. 2 eliminates 2 from being here in the rest of the column. It also eliminates 2 from being here in the rest of the row. Where's 2 in box 4? It must be here. So that's 2. Let's just double check. 7 does not match first position. 2 matches second position. 1 does not match third position. 1 first, second, third, fourth, fifth, sixth, seventh. First, second, third, fourth, fifth, sixth, seventh, eighth. First, second, that could match. Third, we're never matching fourth here, wherever it is. But you could do something funky like that. So we're never matching fourth. We could match second. So this could be 1, 2, 3, 4. Technically could be 9. But we're not matching first. We're not matching fourth. So then this has to be 2 through 7. Obviously no 4 here because of the 4 being with 2 and 8 in the 1 to 2 ratio. This digit is between 2 other digits. 2 unique digits that are 5 away from it. So this cannot be 4 or 6. It can't be 2, 3, or 7, so this has to be 1, 8, or 9 here. This is 3. It must match 3. This cannot match because it can't be 4. So we have to match 3 others at least. So it must be 5, 6, and 7. Or 6, 7, 8. Or 5, 7, 8. Okay. This must, well, This could be any digit that's not 5. This could be any digit not 5. Can we actually match 7? It would be 4, so 1. The first position, 2 would match. 3 position, 4, 5, 6, 7, 8, 9. So we could match 7 here. That actually could be correct. Again, for this segment, we can't... Okay. We could do something like this and exit out that way. We could also do something like this. So we can never touch this as on this segment. Right? We need 3 more. So it could be 1, 2, 3. It could be 1, 2, 3. So I don't think we can ever reach that spot, right? This can't be 1. To enter this room, you'd have to enter this way and enter this way. And the problem is, so you could, okay, so you have to match 5, 6, 7. So if the FP were to go this way, actually, okay. So if P, how could P match these cells? One doesn't, the first position doesn't match, second position, third, and fourth position don't match. You could match 5, you can't go 5 there. But you could match 3 if it goes whatever here, 6, 7, 8 there. Does that actually work, though? So let's try P going that route. This can never be 5, so that wouldn't match. These would all have to match then. So this would be 6, 7, 8. We'd have 6, 7, 8, which would force this to be 9. This couldn't be 9, it'd be 1, and then this digit would not work. So we cannot go that way. So again, this doesn't match. P has to go this way, then guaranteed. Then P goes that way, and that's never going to match. So this must match, and this must match. Because we can never be on the plate, because then this would also be 3. So P has to go this way, cannot go there, it has to go that way. So she must exit out this way. This is then 5, no 6, 7, and 8, which means this can't be 7 or 8, it's 9. 7 is only in 5 away from 1 here, so because we can't have, therefore that 4 eliminates 4 here, so that's 4. This has to be 6, and there's no way this can be touched as a, because that's not going to have 6 digits there. So no 5 or 6 here, because of 5 or 6 in the column. 9 eliminates 9 here. 8 eliminates 8 here. Remaining digits of row So P has to come from this direction. Guaranteed. Could go all the way around here, though. So we don't know about that aspect. Remaining digits of... Let's do row 4, row 5, and row 6. We have 2, 5, 7, 9 in row 4. Row 5 is 1, 3, 5, 8. And row 6 has to be 4, 6, 8, 9. This is never matching. This is never matching. This could match. So this is 1, this is 2. This could be 3 and matches. Can we ever connect this way? I guess it could be 1 here, 1 matching here, and then 4 and then something. So that's possible. This must go through either here or here. This cannot be 1, so this doesn't match. Six is in a 1-to-2 ratio with 3. So the third can never match here. Eight eliminates 8 from being here. Well, okay, let's do remaining digits then. Remaining digits in column 4 have to be 4, 5, 6, 7, 8. So no 6, 7 here because of 6, 7 in the row. No 4 here because of 4 in the row. No 5 here because of 5 in the row. This can't be 4 because we guarantee have a 4 here in the black courant. Okay. Remaining digits in column 5 are 2, 3, 4, 5, 6, 9. Well, this has to be 5 apart from each other. The only high digit that's possible here is 9. 6 has to be next to a 1. So therefore, one of these is a 9, which eliminates 9 in the rest of the column. This can't be 2 or 2, 3, or 4. So this has to be a high digit, and it can't be 5, obviously. So 5 can't be there, and 6 can't be can only be next to 1 on the grapes. So this has to be 9 here. So that's 9 next to 2, 3, or 4 here. This can't be 3 because of 3 in the box. This can't be 3 because of 3 in the box. No 6 because of 6 in the row. So we know 3 has to be one of these two. We have a 2, 4 pair in column 5, which eliminates 2, 4 in the rest of the column. Also, this is 5 apart from each other, so this must be 6. This can't be 2 or 4. It's 5. This must be 3. And this has to go this way. So that means this is matching. That's 3. This cannot be 3. This is either 2 or it's 7 here. Interesting. 5 eliminates 5 in the rest of the box. Okay, 6 eliminates 6 in the rest of the box. Remaining digits of column... we have a 4-8 pair in column 4, which limits 4 and 8 in the rest of the column. So no 4-8 here, no 4-8 here, no 4-8 here. The 6-7 pair eliminates 6-7 in the rest of the column, so this can't be 7. This is 5. That means remaining digits in column 6 then are still 1, 2, 7, 8, 9. So no 1 here because of 1 in the box. No 2 here because of 2 in the row. 3 eliminates 3 being here. So this is 8, 9. Where's 3 in box 7? It has to be there. So that's 3. 9 eliminates 9. And 9 and 6, 7 pairs a pair. Eliminate 9 and 7 in the rest of the box. So this has to be 1, 2, or 8. If this matches 2... So this is never going to be reached because you can't enter here and then exit back out because you without crossing yourself. I don't think this can ever be 2, actually. How is this going to be 2? If this is 2, this is 4, 8. Actually, it could be. You match 3, this is 4, 5, 6, 7, and then exit out. Or 1, 2, 3, 4, 5, 6, 7, and then you exit out. So that could actually be 2. Ooh. We definitely know 7's one of those 3. Remaining digits in row 7, we have 2, 4, 7, 8, 9. So this is never matching here. As a 1. This is, well, it could be a matching 2 there. This is never matching 8. There's no way. It has to match 1 or 2. It's not matching 8 because we have... You can't form a set of 8 digits with them matching their position here. Can it be 2? Is kind of the question, right? If this is 2, this is 4, that's 8. 1, 2, 3, 4. So 3's not matching. A 1 is one of these. 1's not matching, obviously. 2's not matching. It has to be one of these. So 1's not matching, 2's not matching, 3's not matching. If this is 2, so what happens? If we have 2 here, this is 4, this is 8. 1, 2, and 3, 4 are not matching. So we could have 1, 2, 3, 4, 5 could match. But then 6, 7... Yeah, you can't have 2. It has to be just 1 matching. So this is 1 here, which means this can't be 1 here. We have 1 matching. Obviously, 1 is not going to match there. 9 is not going to match. 1, 2, 3, 4, 5, 6, 7, 8 could match. So can you ever match the 8 without having 5 there? And I think the answer is no, because you would have to cross or do some funky thing. Which, yeah, you can't go here and then go back and cross back to it. So this cannot go here. It has to either connect directly here, which means it's there. So say we connect directly. The problem is none of these match then, right? 1, 2, 3, 4 in either position. None of them match. So we cannot go directly there. We have to go around. 1, 2, 3, 4. Again, that doesn't work. 1, 2, and then so if we go that way, we have 1, 2, 3, 4, 5. Again, we can't match any of those. So it has to go this way, which means it has to go around, which means this 5 matches. So 5 matches. This is 1, 2, 3, 4. 4 could match. 4 cannot match because we only have 1 matching here. Right? If we have tried to have 2, that forces us to be 4. That's 8. And obviously, we only have the 5 matching in that case. So this cannot be 4. It's 8, which makes this 2, which makes that 4. 8 eliminates 8 here, so it's 4, which makes that 2, which means this can't be 2. That's 7. So we have 7 matches, so we must match here, we match here. We cannot match here. We must match all of these then. So then this has to go this way. F has to go here, through here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 8, this is 9. 8 eliminates 8 here, so it's 9 and 8. 9 eliminates 9 here, so it's 8, which makes that 5, which makes that 9. 8 eliminates 8 here, so it's 9 and 8. None of these can be 9. None of these can be 5, and none of these can be 8 here. Okay, so we have 7, 8, 9 matching. We could continue here. We could continue here. Remaining digits of row 1. 1, 3, 4. Remaining digits of row 2. We have 5, 6, 7, 8. And remaining digits of row 3. We have 2, 6, 7, or 9. Okay. If we go this route, so we could go this route if it specifically goes this way. If we try to go this way, this is only going to have you would have to have 2 matching at most. And how would you do that? Well, this wouldn't match. You go here. You try to go around here. None of these can match, right? If this is 2, this is not going to be 2 here. This is not going to be 3, not going to be 4, not going to be 5. So you cannot go that way, but you could go this way, right? Here, then 2 matches 2. No 3, no 4, it could be 5 or 6 there. Right. So if we match 2, we could do something like that. And that could work. What about going this way? If we go this way, you could have 1, 3, 4 matching. That's fine. This doesn't match, that doesn't match. This could be 3. You can never have 8 here. It's never going to match 8 cells because we are already missing 2. So it's 1 or 3. This can never match 9 because we don't have... Okay, this can't be 7 or 8 here. So again, cannot match 9 because we already have a non-matching here. So it's matching 2 or 4. Can it actually match 4? If we try to match 4 here, the problem is... We have 4 here. It has to match these. This has to go this way then. But then 4 doesn't match. So this has to be a 2. So this is 2, which eliminates 2 in the rest of the rows and columns. So we know 2 has to be one of these 2. 2 has to be one of those 2. So we're matching 2. This is the second digit, so that's matching. This cannot be 3, so it cannot go straight down. Could go something like that. Remaining digits of row 8. We have 5, 6, 7. Remaining digits of row 9. We have 1, 3, and 8. Okay. We cannot go directly here. We can't cross anywhere here. So I think we have to go around this way, right? We can't go that way because that would block this. Okay, F has to go this way. So this has to go around that way, right? And this is not going to match. This is not going to match, so this has to match. So that has to be the 5th match. Because these two are not going to match either. So then this must be 5, which makes this not 5, that's 7. No 7 here, no 7 here, no 7 here. Obviously no 5 here. No 5 here. That means F has to go this way. Obviously, this cannot be 8. We have a 1-3 pair now in column 8, which eliminates 1 and 3 in the rest of the column. This can't be 1 or 3, it's 4. That eliminates 4 from being here or here. This can never be 1 anymore to match if this were going this way. 4 eliminates 4 here, so we have 6, 9 as a pair in column 8, which eliminates 6 here, so this is 8. That eliminates 8 from the rest of the box. Can this ever be 3? It can obviously be 1. So this is not matching as the 4th. If we try to match 3, this will no longer match. We could have a 1 here, but that's 2 at most matching. So this isn't... Okay, this is never matching because it's not the second. It's not 2 as a second position. And we cannot have both of the... 8 is going to be one of these, and it's not matching. So this has to be 1. So this is 1, which means none of these match. So this cannot be 3 here, because that would match. It's 8, which makes that 3. 1 eliminates 1 here, so that's 3. So we have 3 matches here. If we go directly here, that's not gonna, none of those going to match. So we have to go around. So P has to go this way to connect. We have 3 matches. 7 doesn't match. 5 could. This is not... 6 is not going to match. This can't be 3 or 8. It's 1, which makes this 8 there. That's not going to... 8 doesn't match 6, the 6th position. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 7 doesn't match. 8 doesn't match. So we have to match both of these, which means this is 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9, which makes this 6, which makes that 4. That makes that 2. Where's 2 in row 3? It must be here. 6 eliminates 6 here, so it's 9. 9 eliminates 9 here, so it's 4 and 9. 5 eliminates 5 here. 3 eliminates 3 here. This is 1. That's 3. If we go this route, that's 3 in the corner. We celebrate because we're close to solving it. If we go this route, the problem is... Yeah, again, if we go this route, the problem is 1 matches 1, and 3 would match 3. And that's already 2 greater than that, so cannot go this way. So P has to go this way. It must match the 2, has to go that way, and then must go... This is 5. So this is 5, cannot be 2 or 9 here. And these are not the path. So these are not path here. We have to go this way because we can't cut off there, and because these don't match. So these do not match. This does not match. And this, because if we try to connect there, that would not match. So it has to go through the 5, which must be the one that's matching. So therefore, this can't match. Whoops, not red. That's green. So 5 is matching. 1, 2, 3, 4, 5. This cannot match, though. And this is the path that P takes. So this cannot be 6. It's 7, which makes this 6, which makes that 7, 6. It also makes this 7 and that 6. Experiment completed successfully. Test date, February 18th, 1975. Cells visited, 73. Hit counters activated, 12. Black currants eaten, 1. Grapes eaten, 1. The rats remain as focused as ever, but I'm not sure if the same can be said for myself. Elliot's after-hours productivity has been occupying my thoughts this week, and numerous times today I caught myself wondering exactly what it is he's working on, and why he feels unable to share it with me. This curiosity has led to an idea taking root in my mind, one I'm not necessarily proud of. Those miniature cameras from last week's tests could feasibly serve a useful secondary purpose. Ooh. They're going to be spying on Elliot, it looks like. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.